I'm Eric Peterson, as she mentioned. I founded a company called Origami, and we work in VR and AR. And now that I have you captive here for like a forced 2 hours of conversation, I want to give you a brief overview of what those next hour and a half, 2 hours are going to be like. So I think the first question you're probably asking is, why Eric? Or why Origami? Like, what's special about you? Why should you talk about these topics? So I'll answer that question. VR, AR, MR, XR. We'll answer what all these R's are. Why are there so many R's? We'll tell you. We'll tell you what each R is. Value for architecture. So I think this is the one where you probably, if you want to sleep for like a part of it, wake up for this part, and this will be like the important part. I'll like ring a bell or something so that everyone who wants to take a nap can wake up. Current state, we'll be discussing like where are we right now in kind of this type of VR, AR application in architecture. And then last, I'm going to do Peterson's guide to this space, to XR, to VR, to AR. What rules should you follow so that you're going to A, be successful in the space, and then B, not risk a lot. So the first one, why am I a good person to talk on this issue? So I've been thinking about it for a long time. I think that's the most important one. I know that's not the one that most people would want to hear. Most people want to hear like pedigree and stuff. And so I've got some pedigree stuff I can throw down. Like I went to Columbia University. I worked at Goldman Sachs. I worked at Microsoft. I worked at Indiegogo. So I've got a little Silicon Valley. I got a little, high-end corporate. So I have a strong pedigree background, but that's not as important as the fact that I've been thinking about virtual reality and augmented reality for 15 years now, or more than a decade. In 2003, I was working in the VR AR lab at Columbia, and the technology was terrible because it was much older versions of what you guys are going to get to try out today. But you could see the future in that. You could see what was coming down the pipeline. So it was definitely a decade away from being an actual useful tool, but it was, I was building on military equipment, building like game engines where you could shoot rabbits or something. Like the actual work of figuring out how to make these things run and how to make them run well, I was getting to try out way in advance. So I've had that now 15 years to think about all the problems that are coming down the pipeline for this whole pathway. And so that long thinking is what's going to be valuable for you guys. And so I'm going to tell you a really quick story as a way to get you into my brain and why I'm so excited about the space. That'll also give you a little bit about my background. So when 2015, the whole VR thing was starting up again, and I was interested in finding some work that would be in the space that would allow me to test out some of my ideas. I found an ad in Toronto about Toronto Rehab. They were actually going to apply VR to stroke patients. And that kind of intrigued me because that's a very powerful thing. So I went down to meet and talk to this researcher about what they were going to do. So we first met, we talked about the Oculus Rift and how cool it was, and how this cheaper version of the technology was really going to unlock the potential for everybody to start using it. This researcher didn't have massive budgets, and so now that the Oculus was like $300, he could actually start using it and actually testing with patients and stuff. So I was talking to him. We got past all that discussion, and we got to the point of like what he was trying to build. And he told me that he wanted to build a mirror box in VR. Show of hands, who's heard the term mirror box before? One, we got one. So she's way smarter than I was back then. I had no idea what a mirror box was. So he described it to me pretty quickly, and luckily you guys get a picture. That's going to help. The mirror box is a simple apparatus that allows you to work with a stroke patient who has two limbs, one that's functional and one that's not functional. So what happens with a stroke is your brain starts to lose resources super quick and freaks out and starts shutting down channels of control to the body. And so in some cases, you'll see like certain parts of the face stop working, arms will start working, So that like triage event shuts down the pathways, but there's nothing wrong with the arm, and there's nothing wrong with the face. They're still totally functional. And so what happens with the mirror box is you have this right functional hand, you have this totally functional left arm that no longer gets signals from the brain, so it's limp and dead. And what you do is you have the patient looking into the mirror so that their right arm is mirrored over their left arm. So it looks like their right arm is their left arm. You give them dumbbells, they do a little bit of exercise with their right arm, and all of a sudden the brain sees into this mirror world that, oh, my left arm is also doing the exercise, which is kind of interesting. But the amazing thing is what happens inside the brain after that. The brain starts sending signals back to that arm. It says, way to go, arm, good work. Like the success signals start going down. And so it actually begins to reopen the pathway for that limb to start working again. Which is, I mean, like when I heard that, that was incredible, right? Like all you were doing was just having somebody look in a mirror, and it was able to like reopen neural pathways in the body. And so what really was happening there, which is very powerful, is this mirror universe that existed inside that space was interacting with the reptilian brain. So the brain is kind of divided into a bunch of different parts that have grown up over our evolution. And the reptilian was the first part of the brain. That part of the brain handles most of the autonomous stuff, like when you're moving, like when you're breathing, your perception of the world, all handled by the reptilian part of the brain. It's not conscious at all, so you don't have access to it with your conscious mind. It's something that's automated underneath everything. And so what happens in that mirror box illusion is you are tricking the reptilian brain into believing that the arm is there and doing that work. And so what happened for me was when he said, you're going to build a virtual version of that, I realized that there's a huge power in virtual reality, which is we get to jack right into the reptilian brain and provide it with a perception of the world that we can control. There's a lot that can happen there. You can heal a dead limb. There's a lot more that can happen there, right? The potentials are kind of amazing. So that brings me to what virtual reality is, right? Virtual reality is the replacement of the perception for the reptilian brain. Whether it's audio, visual, any of those cues, it's about just giving it a new signal. Saying, here's a new signal, and you can do it in many different ways. And right now, the main way is to have a goggles on your head, and they will project the new light rays into your eyes that represent the space you're in. But there's a whole lot of different things to do with it. And so, it's a pretty broad and ambitious statement. I think this is a good quote from John Carmack about the virtual reality. At its very core, it's really just about replacing the limitations of the actual world. So are you guys excited to see what these devices look like that are going to do this? Yes, it's going to be amazing. Okay, here it is. This is the 1990s, right? People had this vision already. They understood what the technology was going to be able to do, but the technology wasn't ready in the 90s, right? This may have been the first point that some of you had access to the idea of virtual reality, was this attempt in the space. It was pretty terrible. The tracking was terrible, the frame rate was terrible, it made people sick all over the place. Everything was corded, and these aren't just normal cords, these are giant PVC tubing attached to your head. It was just untenable, not usable. So this is just a bunch of stuff that was available in the 1990s that we're looking at this vision and saying oh, we can create some stuff that's going to do this, but it was not there. It was not ready to actually replace that reptilian signal that we were talking about. But you can kind of see there were the beginnings of what we are seeing now back then. People were trying to pull it off. So at a certain point, people said okay, well we can't, we're not actually successful right now with pulling off VR. And so VR kind of took a hiatus and went into the cultural world. It became a pulp culture thing, right? People started exploring the ideas using stories rather than actually technology. So Lawnmower Man, they had really weird visions of what happens inside virtual reality. For some reason, they didn't think, oh, we're just going to use things that look like real life. No, they have these weird technology creations. Johnny Mnemonic. Some of them you might not have seen, but are actually pretty good movies. Existenz, Strange Days, throwbacks for anybody who was into techie movies in the 90s. I don't know if you guys have ever seen this one, but again, it's a weird thing. Like, why is it all green and like gross and techie? Like, virtual reality should kind of be nice and utopian, and if you can replace what people see, why would you do that? Anyway, 2012, something changes, right? Like, there's a big moment in 2012, and the big moment is a 19-year-old kid in his garage in California, Palmer Luckey. 19-year-old kid, turns out to kind of be like a weird dude, but he built a VR headset in his parents' garage. And you can see it here, the first demo prototype. This is actually duct taped together. You can kind of see the duct tape lines on there. What he realized that nobody else had realized at the time was the components of mobile phones actually work really well to build virtual reality devices. You have an accelerometer, a gyrometer, so like that's the movement part. You have a display, a high-resolution display, so that replaces your vision. And you also have GPU computers that are now like powerful enough to start rendering some interesting things. So he just was the first person to put all these pieces together and to realize that that was a moment. And he kind of sparked a big shift in the space. And this was like the Oculus Rift Kickstarter. It's what got me interested in the space again. It's, it brought in tons of like big brains from the game industry who were working on, gaming stuff and like jump ship automatically to work on this. And then, created really simple versions of that early kit, like the cardboard. I don't know, probably a lot of you have tried something like that. The Gear VR, another example, where you're really just kind of like moving in 360. It was the start, right? It was a start. And his company was bought by Mark Zuckerberg for $2 billion. And that was the moment where like it wasn't just a kid in like a small company anymore. It was like, oh, this is going to be a massive industry and people are going to make a ton of money. So that was what really shot everyone forward in the industry and started seeing a huge amount of investment. So this is HTC making a product. This is Microsoft making a product. Everyone started building some hardware because they knew this was a new platform that was forming, just like mobile had in the recent past. Big problem. All those wonderful photos that I showed you where people were using the devices and everything, they didn't show any cords, but everything was still corded, right? This is the PlayStation VR setup, and doesn't look like a Steve Jobs friendly device to me, right? Doesn't look like a wireless, ready to go, easy to set up device. So it's not consumer ready yet. This person has to like mount the cameras on their wall in their house and like string them along. This is not consumer ready yet. It feels a lot like this, right? Cords, like how far away are we from this right now? Not that far, but something's going to change. Something has actually changed today. Literally today at 1:00 p.m., there was an announcement in California. Facebook specifically, the same company that bought this guy's company, announced an entirely new device that is actually consumer ready. It's a fully no setup, no computer, no wires, fully standalone device. You just put it on and it just works right away. You like map out a space on the floor that you want to be inside of, and then all of a sudden you're inside VR and you use it like kind of a tablet. This is the beginning of a new wave of technology in virtual reality that is going to shift things forward because it won't require an expert in a company anymore. It won't require an expert at home to set it up. It's just going to be as easy as a tablet. Very simple. All the interfaces are like point and click using your hands, just like a tablet. So the next category that I wanted to go over, the R's, more R's, AR and MR. AR is augmented reality, MR is mixed reality. I don't need, it's not important you know the difference between these two things. I want you to look at them as one big bucket. But essentially, it's still the lizard brain. We're still replacing some signals for the lizard brain, but we're not replacing all the signals. We're just looking at adding objects into the existing world. So like, I'm gonna put like a dinosaur on the table so I can still walk around it so it feels like it's really there, but that's augmented reality. So like here you got an example, right? This individual here is using a HoloLens. He's looking at this hologrammed element sitting on the table. It looks nice, right? Just like the marketing photos we saw for VR. Looks nice, looks usable. here's a really big one, they got a project, a bunch of people working together, this is future, so cool, we can all do this. Like, it really feels like this is gonna be a useful tool, right? Because like, imagine just this thing just being on your table and you can talk about the site that you're building or whatever. Problem is that right now, augmented and mixed reality is kind of back in the 90s where virtual reality was before. It's not really ready yet, but they don't talk about why it's not ready yet. The main thing is field of view. So if you want to trick the reptilian brain, you have to fill the whole field of view. In this case, we're dealing with, the first HoloLens had a 30-degree field of view. That's like taking one of these cards, that I've got here, holding it up in front of my face like this. And like the hologram's inside the card, but like everything else is no hologram. The HoloLens 52 field, it's like a little bit closer. But really it's more like kind of holding a tablet in front of your face, like at around this length. Which, if you think about it, why wouldn't I just hold a tablet in front of my face? Because then I don't have to deal with like the weird see-throughness of holograms. I can actually just really replace things in the real world. And we'll actually show you a demo with a tablet later. I think that that's really what's the usable stuff in AR and MR right now. And VR, like AR right now is really kind of a military product, mostly. HoloLens sells 2 times more units to the military than they do to anybody else. So the military basically owns that whole pipeline right now. And that's where it makes sense, because that's where it all started, right? Like AR technology, VR technology, a lot of these things started in the military. And it's going to be there for a while. And if you want to know when it's ready, just get in contact with me and I'll let you know when it's ready. It's going to be ready in a little while, probably 5 years or so. But like AR and MR both have one big restriction, which is display technology. And there's serious physical limitations that don't allow you to display bigger than that field of view right now. The only company on the planet right now that could probably do a leapfrog and do it earlier is Apple, if they decide to do it. But Apple does not usually like to jump into a market first. They like to jump into a market last and then dominate it. So I don't think we will see them kind of jump in just yet, maybe 2021. This is where AR is useful right now. And you guys will get to use all this stuff, right? It's on your phone. It's on a tablet. It's like tracked in 3D space. You can get actual directions for where you're going. It'll show you giant arrows on the street. You can do fun things with like taking real buildings and putting animals on top of them for promotional material, things like that. Snapchat has like a pretty interesting AR push that they've done. And I think that's where AR kind of should live right now until it's ready to actually perform much more serious tasks. I mean, I think in some cases, if you're looking for, maybe in deep industrial stuff where you want to give frontline workers like instructions on what to do, AR and MR can be useful there. But for like a grand, like everyone should start trying to use it technology, it's not quite there yet. So I want to break down VR and AR and talk about like their differences and similarities a little bit. And I want to do it by looking at the core technology and taking a step back and looking at a new technology that came before it. So mobile phones are the most recent kind of big change in technology. So we had all the desktop PCs, everyone was using desktop PCs. 2007, Steve Jobs came out and like did his presentation about the iPhone, and then that basically blew up everything. And so now we're all using mobile computers, right? Like PCs have now been thrown into the dustbin of history. Their use is like so down in compared to mobile phones. Mobile phones now dominate. And I think one of the major questions I want to propose is that there are a couple of key enabling technologies behind the mobile phone revolution that you don't necessarily think about all the time, but that I want to really highlight so you get a good view of a kind of metaphor for the VR space. So the key enabling technology that I find most useful in my phone is GPS. So GPS, you guys are all aware, it like tracks you in 2 dimensions on the Earth. Like where are you on the map, essentially? And GPS had been around for a long time, built by the military, allowed cars to navigate. People had Garmin's, things like that. But when the 3GS came out, so when the iPhone, the second generation of the iPhone came out, they added GPS to the iPhone. And all of a sudden, an entirely new class of applications was made ready for their world. You know, Uber, Ritual, like applications that allow you to have location-based fun things like Snapchat, where you have the dragon in the background. Like, I think that in general, if you think about some of the most important things your phone does, GPS is a big part of that experience, a big part of that mobile computing experience. Because it's not just about, oh, I have access to the internet on my phone. It's about the phone knows where I am and gives me contextual information. You know, that's a big part of it. So augmented and virtual reality has an enabling technology like that behind all of it. And it's about tracking not just in two-dimensional space, but in three-dimensional space. And it's about tracking not at a road scale or a street scale, but at a human scale. So the tracking technology that's behind all this new sort of AR, VR is like millimeter level accuracy of tracking of the movement of devices and humans in spaces. And that's really, you know, the key technology that I want you to think about when you think about this space. I don't want you to think about the displays, because they're going to change so fast. I don't want you to think about, you know, headsets or tablets or anything else, because that's all going to change super rapidly. That's like interface stuff. I want you to think about the back end, the stuff that's actually driving the innovation. So what does it do? When you have the ability to track an object in full three-dimensional space, what does it allow you to do? And like, just to tie it back to what I was talking about before, it gives you access to the mirror world that you can decide, you know, about, that you can control. So this is just like a simple application where the phone is tracking itself in full 3 dimensions at the millimeter scale, and it, you know, you can create this illusion where there's this whole world inside this phone that doesn't actually exist. So what I want you to do about AR and VR is forget everything that you currently know and associate with it, because it's not going to be helpful for you if you actually want to do stuff in this space. You want to forget about the past of augmented reality and virtual reality. You want to forget about the current goggles and the headsets and everything else. And like, maybe we just do it in this room with us right now, and we'll go back to thinking about those things later, but like, come with me right now and just forget it all. And let's start from scratch and start with that, just that tracking technology. And let's imagine we have a magic machine. And that magic machine just takes information that's 3-dimensional and manifests it in reality for you instantly with no understanding of anything. Just like magic, like holodeck magic, like boom, it's there in front of you. Whatever you want, everything is there in front of you. You can get access to it. That's where I want you to sit with me for a while. Let's just keep that machine in the back of our heads when we talk about this space. So I want you to let go of VR and AR and MR, those terms, right? We're letting those go. XR is like the whole space, all of these technologies. I think spatial computing is a good word to use to describe it. Spatial computing, if you think about it, you know, we had desktop computing. We had mobile computing. We're now going to move into an era of spatial computing, which means digital realities are going to live with us, manifested in the spaces that we currently live in. So everything that currently lives in the digital world will live in our world as well, in the space. And we can move into the digital world equally. And so when I talk about the value conversation, so ring-a-ling-a-ling, everybody wake up now, right? Like, the value conversation is what's important here. Like, how is this going to be valuable to you and your industry? I want you to think about spatial computing, because that's going to allow you to actually think about the real value that's coming in the future, not like what's there right now. Because that's how you need to plan, right? You need to plan for the future. So when I talk about value, I want to use a couple examples from architecture specifically, where a new technology has completely changed things and added enormous value to the industry. The first one, John Herschel, 1842, he was like a chemist and an astronomer and a bunch of other things, but he invented a technology that was really important to architecture, and that was blueprints, right? He invented the technology that allowed you to take someone who traced, you know, a giant drafted drawing and copy it really cheaply. Like it was literally just a making things cheaper situation. It wasn't anything more than that. It was 10 times cheaper than hiring some, intern to trace it out for you. So that was like a huge important shift. And what did it do? It meant that you could have bigger projects because you could share the information more broadly. It meant that you could be more ambitious because you could share the information more broadly. It meant that you could, share between teams. You could have a bunch of different siloed groups that handle different parts of the architecture process much easier. Does anybody know what this is? No? I didn't know before I actually looked it up either. This 1985, this is the first computer-assisted architecture design tool. This is like Carnegie Mellon University. So this is, you can see here, this is like a drafting drawing being printed out from the machine. Crazy, like this is like a giant refrigerator of an item that you had to deal with. But once again, this is another shift in architecture technology. And what it did was it made things cheaper and it made communication easier, right? It allowed you to also start accessing something that had never been accessed before, which was three-dimensional data. So in the past, you had to actually build stuff in reality to see it in 3 dimensions. You had to build models. You had to build, actual physical scale models, or you actually had to build a whole environment. This allowed you to experiment in 3 dimensions and then print it out into that 2-dimensional form that they used to communicate to everybody. And once again, it was much cheaper than Blueprint. And so all of a sudden, you could do bigger projects, you could share more liberally, you could silo the teams so that you had like one team that was like specialized in this space and the other on the other. And it just allowed people to get more ambitious, make bigger projects, take bigger risks. So this is what I'm talking about, the value in spatial computing. And I'm just repeating kind of these points, right? It improves sales when you can communicate better. So like with these blueprints, you actually had a much better history of all of your drawings that you could show off in future conversations with clients. It reduces errors, right? When you have the ability to communicate more with people in a more accurate way. You could do bigger projects. Again, more ambitious projects. So I'm going to talk about today again. We're going back to the present, right? Our magical machine is still there. That's still what we want to use. But let's talk about what's currently in the market and what's currently being used as a first step. So we've got 360-degree images, 360-degree video. This is like the cardboard Gear VR type devices that we talked about earlier. And that's kind of like the first wave that happened after Palmer Luckey had that insight that like mobile technology can be used to make VR. So one of the things is workflow is right. For those of you who have tried it, just a quick show of hands. Who's worked with 360 images or video? Yeah, see, like that's 50% of the audience. It's a pretty good chunk. And I think the reason is that the workflow is right. Like, you don't have to be a huge expert in the space. You can kind of print it out from existing renderers. You can easily see how it works. It kind of operates like an image, right? So it doesn't have to be this new pathway where you're like working with a game engine or working with transferring the models into a real-time game engine. But I think the key for 360 videos to understand is that it's not really part of our magical object universe because it's not in that spatial data category. You don't actually, it's more like having kind of like a 2D render that you wrap around your head, and it gives you a really interesting way to look at 2D renders. And you can have a 3D aspect to it, like kind of like 3D movies, but it's not spatial data. So you won't get the sense of the actual size of the space. You won't be able to move in the space. So it's not part of this like spatial world that I've been talking about, the spatial computing world. It is, however, a really good kind of gateway drug into that space because it gets you thinking about it. And it allows you to experiment with it. And so in my set, like in how I look at this, it's like it's been an amazing thing for the industry because it allows people to get creative and to get their hands dirty, and that's an important first. So there's another category, which is kind of the add-on category. So there's a bunch of existing software developers who already provide services to architecture, and they are trying to find ways to bring in VR because they know it's going to be valuable. And that's one of the reasons why you know that this industry is going to take off because even the most entrenched, biggest software players are already trying to make it happen on their platforms. I think one of the problems here is that it's not built from the ground up for virtual reality or for spatial computing in general. And the problems that cause are many, but the main thing is that performance becomes a big issue. So I want to talk really quickly about simulator sickness. Has anyone ever experienced a little bit of like motion sickness after trying VR? Yeah, a few. So I'm in that group. I'm super sensitive to motion sickness inside VR. I have a really high refresh rate in my eyes. And so that means that like every refresh that happens in your eyes, it does a check, like, is my movement lining up with what's happening in the real world? And so there's two ways that you can get sick. One is like 360 video, where you're kind of stuck in a static place, right? And you're moving around like this, and that's like the movement you're allowed. And if you do anything else that's like not that, then it doesn't respond to you properly. And so what happens is your brain has an acceleration going on in the inner ear, right? There's an inner ear kind of liquid that tells you that you're moving. And then your eyes don't see that same movement inside VR. And so you're accessing that reptilian brain and you're replacing the perception, but you're doing it wrong. And so you make people sick because when your brain and your inner ear don't match, that's usually a sign of poisoning in most people. And so if you're poisoned, then what are you going to do? You're trying to throw up whatever you just ate. So that's the signal, right? Like that's what happens when people get motion sick in VR, is it's a conflict. You're powerful now as a creator. You're getting access to that reptilian brain, but you're providing it with information that is not real. And so you're making a mistake. You're not giving that access to like this movement, which is one of the key parts of how we perceive depth, actually. So like, I don't know if you know this, but everybody has micro movements in their body, super tiny movements. No matter how still you are, you're having micro movements in your head at all times. And that's part of how we perceive depth, because we see the difference in the world. And you do it yourself, like right now, you'll see parallax. Everything that's closer to you moves more. Everything that's farther moves less. It's one of the key parts of how humans perceive depth. So if you're not getting that from the signal, it makes you sick. Now the other way it can make you sick, and that's more relevant to this group, is if the frame rate is too low. It's the same general idea. Like if you're updating frames maybe 40 times a second or 50 times a second, then you're going to have moments where you're moving, but the signal isn't moving, right? It's that same problem now, but it's just broken up into different parts. So that problem still maybe happens less than it would in 360, but it still happens. It happens maybe every other frame or something because your movement is not timed up. So the Addon right now, the Addon situation is pretty problematic because these teams are not used to doing real-time rendering. And so it's hard enough for them to just get their models to render in real time at a good frame rate. And not only is it hard for them to do that, but they have to do it for VR. You have to do it at, like I said, 90 frames per second, 120 frames per second. So if you can't normally get it to run at 30 frames per second, and you're also dealing with a lot of different types of data at different complexities and different sizes, it's a very hard problem to solve for these companies. They're trying to because they know it's valuable, but it's a hard problem for them to solve inside that space. So there's another group, I'll call this the PCVR group, and it's sort of design tools for architecture that have been built from the ground up to work with architecture, to work with building, things like that. This group, I think, is better right now than the Addon group because they kind of are native to the space. They understand what they're building. But one of the big problems is they're reliant on these first two letters. They're reliant on big, heavy PCs with ginormous GPUs racked in there, so they're expensive. They have cords attached to the headsets. And generally speaking, they're not going to be part of that revolution that I kind of highlighted at the beginning of the talk, which is like getting rid of the cords, making it super easy, making setup simple, having no computers involved, having no trackers involved. Right now, this group does not get to participate in that revolution. And that revolution is how most of your clients will try VR for the first time. And it's how most of you might try VR for the first time. It's how the majority of the public will try VR, and probably after this Christmas. Because it's going to be like this year's expensive gift for children who like games and stuff. Because if you think about it, there's not a lot of competition right now. You got the Switch, you got the Xbox, PlayStation. They're all kind of in later stages of their setup. So that's my guess. We're going to see like a big uptick in sales of the Quest later on. So PCVR, they don't get to go along for that train ride into this more consumer-friendly space. AR, so the current state of the art in AR, like I mentioned, is kind of still military heavy. I would say it's mostly experimental at this point. The experiments are really cool and exciting, and it's going to be an incredibly valuable technology. I think that the key is it's still in the space where you require a lot of expertise with the platform. It's not going to be a kind of pick up and use readiness anytime soon. And I think the key limitations of FOV, along with the issue that we got into of the light issue around like having that constant light stream versus a stochastic light stream, you're always going to have this like mismatch where the reptilian brain won't be fully tricked. So in terms of like where I think the most valuable tools are right now in AR for architecture, mostly tablets, things like that. So if you could still get the spatial, you can move around with a tablet, and the tablet can track itself in three-dimensional space. Phones can do the same thing. But you aren't like dealing with these really kind of heavy, big devices on your head that still don't provide you with anything more than the FOV of having a tablet in front of you. So I think that for AR headsets to get to the point where they're going to be useful, you have to overcome what is already just useful with the tablet. So going back to this revolution thing, this new push in the VR space, today, this device was released. I think the key is also price, $400 for the entire computer. Like there's nothing else that you have to buy. This is it. It's a tablet type device. You put it on, you got the controllers. By the way, I'm not shilling for them. Like I don't get paid for my Oculus to like give this presentation. I genuinely think that this is like the best way for you and your teams to try out VR for the first time, or anything really in this space. So that was the first step. You want to forget everything. The second step is you want to be XR flexible. And by that I mean like you don't want to restrict yourself into one of these groups that I talked about. VR, AR, MR. You don't want to like invest too much time in one space because nobody knows what's coming down the pipe, right? In terms of like new technologies that are going to come out and be interesting to you. You want to find a way to take your content, which is the important part, right? Your content that you're building, the spatial content, the three-dimensional content, that is what's important, not the devices. So don't spend a lot of time with devices. Don't spend a lot of time customizing for these things because they're going to change rapidly. So you want to figure out, how do I take my content and get the most value out of it that I can and deliver to all these different platforms at once is ideal. So it's kind of the third step would be enter at a low cost. So that means you want to enter into the marketplace without investing a lot of money or investing a lot of time. Because let's be honest, time is a more like valuable resource than money is in most cases. So you don't want to have like tons of people doing tons of research and trying to become experts in the space. That's not a great idea. You want to find tools, you want to find teams that are going to allow you to offload the expertise somewhere else, and you want to experiment with the experience. You want to experiment with the data, and you want to experiment with your clients and see what impacts them, what's important, like what do they care about in using this data. So that was the low cost section. The next one. Start with no setup. This is very important. Steve Jobs made something happen in the world, and that is he made ease of use in computing a necessity to the point where like when you have computing that doesn't show ease of use, it looks broken. Even if it's not broken, even if it's still functional, if it doesn't have ease of use, it's broken. And like, this is a pretty good example, my laptop, right? Like what was that? Running out of battery during my presentation. Like that type of experience should never happen. And so you want to find devices that are going to allow that ease of use experience to bubble up. So, I mean, like, I know I'm belaboring the point, but this is like a simple video for setup on the Oculus Quest. It shows you this character, this guy. That music actually kind of worked with the scene, right? Like it almost felt like it was meant for it, really light and playful. So yeah, this guy, like you'll see the setup really simple. He just like points at the ground and like sets his play space, and that's it. And he's off to the races. He's inside VR and he's doing stuff. He doesn't have to like set up like, you know, mounted cameras or lasers or whatever. He's just like off to the races. It's a tablet, it's simple. This is your low bar for entry. Do not go down any path that requires you to do anything more than this, because everything from this point forward should make it this easy for you. That means augmented reality, virtual reality, anything spatial, anything in that group, tablets, like it all should be like super simple setup. And so like going back, same thing. This is the Quest, right? That's the reason why I think this is important. And there are going to be other versions of this by other, you know, built by other companies that do the same thing. So it's not just going to be Oculus products, and it's not just going to be the Quest. But for now, this is the starting point. This is the spear that's like pushing forward in the space. So just going back to that value thing for spatial communication, right? For this idea of delivering value for yourself, your customers, your bosses. Just want to like really run over these points again. If you had that magic machine and you could put your future clients into everything that you've ever built and show them your favorite spots in every single building in that first meeting, be like, this is the atrium we built in like 103, you know, downtown street. Isn't it beautiful? Like, this is my favorite spot in the atrium. Okay, that one, yeah, that was, this was like the downtown, you know, club that we built for Johnny and whatever. I'm not very good at making up these names right now, so don't judge me. But like, you get what I'm saying, right? Like, you have this history that you can call up just like images now. But instead of images, they're like spaces. It's your language. Architects speak in spatial language. They deliver to the world and manifest spaces. That's what you guys do. And so why are you communicating in 2 dimensions? Why can't you communicate even internally at your office in 3 dimensions and say, John, I got this idea for the new brick building we're building. We should totally like switch this thing so it's more triangular and the light bounces off of it and it like glows perfectly. Here, I rendered it out for you. I sent it in an email. Just pick up the Quest and see what I'm talking about. Boom, puts it on. I get the idea now. Instead of being like, oh, okay, here's the blueprint, or like, here's the like SketchUp model. Like, move the mouse around and look inside. You can really experience it. Like, this idea of having a very simple access to spatial language is what's going to drive value for you. It's going to allow you to improve your sales. You're going to reduce errors. Think about it. Like, your client comes in for like a, I don't know how often clients come into architecture houses to get meetings and stuff, but like I'm assuming it's somewhat regular, and they like give you comments and they say, oh, I don't like where this staircase is. This should be over here, or like I don't like this thing up there. But like really they're reading off of blueprints, and like they don't know how to read blueprints. Some of these people are just like people who have tons of money. Like they didn't go to architecture school. They didn't spend decades learning how to take 2-dimensional images and drawings and translate them into 3D spaces. So why are you communicating with those tools? You should give them what they speak natively, which is like human experience of space. And you tap into the reptilian brain and you say, you're in the space now, what do you think? Look at how the lighting looks. Isn't that beautiful? Like that is how you should speak when you're talking about spaces. Bigger projects, right? Like once we get to the point where we can start communicating with space, it's not just going to be better communication. Better communication turns into bigger projects. Better communication turns into more ambitious ideas, right? You can sell something that might seem crazy to people if you can put them inside of it. But if you show them like a drawing on a blueprint or like a render in a camera, you can't sell it in the same way. You can't describe, like you can't dance about mathematics, right? You can't sell architecture in 2 dimensions. You need to be selling architecture in 3 dimensions.